All right, great. So our code is starting to look pretty good here. We've got a pick winner function, which will kick off a Chainlink VRF call, and it will return with our fulfill random words function, which is going to pick a random winner out of our array here. But this kind of has an issue, right? We're getting the random number, awesome. We're using the random number to pick a player, awesome. But we're not automatically calling this. Somebody has to call this pick winner function. And we could hope a good Samaritan will call pick winner to end our lottery, but we are engineers. And what do? We work incredibly hard to be incredibly lazy. So what we can do is use Chainlink automation to actually automatically kick off this process of picking our winner for us. If you come to the Chainlink docs, again, we can actually scroll over up at the top over to automation. On the left-hand side, we can look at any of these guides. For us, we're going to go down to time-based automation or custom logic. The documentation here tells us how to actually work with Chainlink from the UI. And we're going to watch a video using the UI for setting this up. However, we're also going to do a lot of this programmatically because remember, we're lazy and that's how we like it. And scrolling down through this create compatible contracts will actually give us an example contract of the actual code we would need to use to work with Chainlink automation. If you want to open up this in Remix and try it out yourself, I highly recommend you do so. But let's go ahead and watch this video from somebody from the Chainlink team explain Chainlink automation and walk us through a demonstration.
Hi, I'm Richard, one of the developer advocates at Chainlink Labs, and today we're going to take a look at an update to Keepers. Now, maybe you're like me, and on a regular Tuesday, you're just browsing the Chainlink documentation, and you come across these Chainlink Keeper release notes. You say, whoa, what's changed? What's new? Let's dive into that and see what's new with Keepers. If you head on over to the documentation and look at the Keepers release notes, you can dig in and see what exactly is new with Keepers. But I want to jump right in and head on over to keepers.chain.link. When we head there, we'll be prompted to connect our wallet. So let's go ahead and do that first. And then we'll take a look at what's new with Keepers. So here, everything looks mostly the same. But when we register a new upkeep, we're presented with this new option, trigger. This is amazing, in my opinion, because one of the most common use cases that I use are time-based trigger mechanisms. And that used to mean dealing with block hashes and trying to figure out how to do all that within a contract, using check upkeep with those block hashes to see if enough time had passed on a blockchain in order to trigger that upkeep. Now, you can do that right here through this UI. I'm going to head back to the documentation and we'll take a look at creating a time-based automation. Now, this will walk you through all the different steps that you need about connecting your wallet, how to register, and everything like that. But let's look at creating a Keeper-compatible contract. This is what we used to have to do every single time. We used to have to create a check upkeep function, and then we had to create a perform upkeep function, right? You remember that? Well, you can still do that if you need some sort of more complex logic behind what's going to trigger an upkeep. If it's not just time-based, you can still use those two functions. But we want to use that time-based function. How can we make a contract and do that? Let's take this sample contract and we'll modify it and go from there. So we have our sample contract. If we click open in Remix, we'll get it popped open in Remix. And Remix is an online IDE for developing Solidity smart contracts. We've got our contract here, and we'll know that this one is based upon the way that we used to always use Keepers, by creating a Keeper compatible contract with check upkeep and perform upkeep, both as functions available within the contract. Now we don't need those anymore. This is a good example, I think, for showing this change, because this contract, it checks upkeep based upon the block timestamp, the last time that we did something, and an interval. So when we deploy this contract, we set the interval. That's what the constructor does. The constructors run every time you deploy a contract. And in this case, we pass in an interval to the constructor. Based upon that interval, you then will check the block timestamp and the last time that we actually performed upkeep and compare them to see if enough seconds have passed in order to need upkeep again. This is a perfect use case for that time-based upkeep. So how do we go about doing this? I think probably the best way to start is by creating a new function to count, right? That's what this contract is doing. It's taking a counter, starting it at 0, and then it's increasing it at a regular interval. So let's do that. Let's create a new function, and we'll call it count. And it won't need to take anything in because we're just going to be increasing that counter. And so we'll just say counter equals counter plus 1. Now, what type of function does this need to be? We can let anybody run this. So we'll say external. And that should be it, right? We have this function count. It's an external function. And we don't need check upkeep anymore for this use case. We don't even need perform upkeep. We can get rid of both of these. Our contract just got a whole lot simpler, right? So anytime that we want to increase our counter, we just call count. Fantastic. Let's go ahead here and see what we have as far as compiling. We have a warning. It's saying that it should not be a keeper compatible interface anymore. That's true. We don't need that as well. We don't need last timestamp and we don't need interval. We'll set those in the keeper's interface so we can get rid of them as well. Suddenly this contract just became really simple. So we create a constructor and let's clean it up all the way. We have our constructor. It's going to set the counter equal to 0. It's a public variable that we can see. And then we have a function to increase that counter. That's it. That's all that the other version of this contract was doing, using check upkeep and perform upkeep. This one, much simpler. And if you're using a use case like this, where you just need to perform an action based upon time passing, this is all you need. So we're good here. We've got our green check mark. That means it compiled correctly. We'll need to deploy this. So let's do an injected provider. I'm going to be deploying it to the Fuji Avalanche Test Network. Just picked one. And we have my account. We need to make sure we deploy the counter contract. Let's go ahead and do that. We'll approve this transaction. We should see it pop up here. We've got another green check mark. That means we're good to go. We have two values here. We have counter. It'll tell us that we've counted 0 times. And we have count. This will actually increment the counter. So let's do that. Go ahead and make sure everything's working before we head over to keepers. Cool. Awesome. We have counted 1 time. Now, let's head over to keepers. And what will we need over there? So we're going to be using time-based triggering for this contract. Now, we'll need to give it the address of our contract. And this is going to give us a couple of interesting options here. So if we had verified this contract on the network that we're working on, it will populate the values of the functions that it can call. We haven't verified this contract. Are we out of luck? We're not. We can get the ABI, the application binary interface. It essentially gives keepers and other applications interacting with your contract the information about, hey, what does this contract do? How do I interact with it? If we head back to Ethereum, we can see under the compilation tab here, under the compiler, we have an ABI. Now, make sure that you pick the correct contract. This contract is counter. So we'll need to make sure we select that, and then we'll click on copy for the ABI. Head back to the keepers window over here, paste it in, and click next. At this point, it should give you all of the functions that you can call. Now, our contract's pretty simple. It has one function. It's called count. So we'll use that function, right? We've told it what function we want to call. Now we need to tell it how often do we want to call this function. when it comes to automating smart contracts on the blockchain, we're going to have to wait for blocks to be verified, right? And blocks to be mined on that blockchain. That can affect how quickly we can do things. I'm going to run this every minute. The Fuji test network is pretty fast. Some other networks, it takes a little bit longer for those block confirmations to come in. That's just something to keep in mind. The syntax here is the same as cron. If you're not familiar with cron, there's a basic breakdown of it over here. It has 5 different values. It's got minutes, hours, days of the month, and then day of the week. Now, you can get really fancy with cron schedules, and there are some tools out there that are fantastic. If you're not familiar with cron, head on over to crontab.guru, and you can kind of get an idea of what is happening. They have an example in here. We'll just talk through it real quick. So the minutes is 5, the hours is 4. The rest are stars. Stars means always. So this says at 4:05 every day. Every day of the month, every month of the year, every day of the week. Right? You can get some pretty interesting things going on. So this one would run at midnight, 5 minutes past it, on like every day in August. Only in August. So every day and every day of the week in August, the 8th month. At 14:15 on the 1st of the month. This is a great place to kind of get a easy, human-readable output from cron tabs. So let's head back here. We want to run this, and I'm going to say every 1 minute. And this is what I mean by interesting things. We can divide up every minute divided by 1. So that's going to say every 1 minute, right? If we had just 1, then it would only run on the first minute of the hour. So at 1 minute past the hour. But we want every 1 minute. We'll click next. And this is very similar to what the keepers used to look like, right? So we'll say count every, now let's do something more fun. Make every minute count. We'll give it a gas limit, 150,000. Should be plenty. We'll pop in some link. Do you need link? If you don't have link, you can get it from the faucet right here. We've got a link to the link faucet right there. We do ask for your email address. That's to email you in case your keeper starts to run out of link or there's a problem. And you can give it a project name if you need to. We'll click register upkeep. We'll need to approve this on the blockchain. We'll wait for that approval process. We'll need to approve one more time to actually request the upkeep as well. So this will transfer the link from our wallet to the keeper's subscription that we've got going on here. And it will set up our upkeep. And then we can view that upkeep. So if we take a look here, we can see the history. We can see, hey, we set up our upkeep and we funded it. We have when it's going to run based upon our cron expression. We've got all that information. We also have the ability to say, hey, I don't want to run this every minute. That's way too often. Maybe every hour. We can go in here and we could edit the upkeep, change things. We can add more link if we need to. We can edit that gas limits. That will be important too. If you have a function that costs more gas than your gas limit, your upkeep won't run. It's just a few things to keep in mind. But you can see here, we've performed our upkeep already. So if we head back to Remix, go back to our contract, right? Last time we ran counter once, and then we had 1 on our counter. If we check now, we can see our counter's 2. And again, in just a minute, we'll be able to see that our counter has increased again. So just like that, we've taken our contract and we've automated it using keepers, time-based triggers to create that decentralized automation of our smart contract. I think that's really cool. This use case, I'm stoked about it because I do this a lot where I want to just have something trigger on a regular interval, a regular cadence, and having the ability to do that is awesome. And it simplifies the contracts down so much, right? Look at this thing. It's tiny. When you compare that to this, My goodness, it's so much easier to understand, so much cleaner, because our use case is so simple. So thanks for watching another tutorial and for checking out the new Keepers version 1.2. I'm Richard, and I'll catch you in the next one.